This is notes for section 9.4, solving using the formula. Actually, I'm going to need to switch that real quick. This is section 9.5. Apologies, not 9.4. All right, today we are using the formula known as the quadratic formula. And the main idea here is that you are going to be using the, we call them coefficients, A, B, and C, from the quadratic formula. You should know them well by now. And we need to solve very carefully. Okay. So here is our quadratic equation, as we say. Y equals ax squared plus bx plus c. And here is we're going to start with a little explanation. Where does this formula come from? And it's the full year of algebra, basically, in 5 minutes. So hold on to your seats and watch how we get down. We start here and we get down to the formula. All right? Then we're going to go through and do the formula, use the formula on 3 different examples. All right, here we go. So first thing is we set the equation equal to 0. That's how we find the x-intercepts, or we say how we find the zeros of a quadratic formula. Now, since we don't have any numbers here, we're going to change this around so we can get x by itself. To do that, notice every time we're going to do something to the equation. So here I had ax squared, and now I have 4a squared x squared. So the x squared stay the same. I got an extra a and I got a 4. And if I look over here, I got a 4 and an a as well. So that must mean the c also gets a 4a. So we multiplied everything by 4a. I wonder why. You shall see. All right, next thing we're going to do is, oh, by the way, if you multiply 0 times 4a, you still get 0. So that's nice. On that side, nothing changes. On this side over here, notice now we have instead of a 0, I've got a b squared. So that must mean we have added b squared to both sides. All right, this by far is the trickiest step of them all, from here to here. You recall we did some factoring a few chapters ago, and if we take this term and this term and this term, all right, and we put them together, we can write those 3 as a perfect square. And that would be 2ax plus b quantity squared. So what we did here is we factored the left side. Notice how the 4ac and the b squared switch positions, and the 4ac just gets left out here. So sad. All right. Then I'm now going to move this to that side. So I'm going to get b squared minus 4ac. So we subtract 4ac from both sides. Then we come to the step that we used in section 9.2, where we get rid of the square. How do I get rid of that power of 2? We take a square root of both sides. So the square root and the square cancel. In fact, let's say radical. We use a radical to cancel both sides. So inside the radical now, we have b squared minus 4ac. Now we're getting really close. We just have an x here, which means I have to get rid of the b, and I have to get rid of the 2a. So I'm going to do the b first of all, cancel it by adding negative b to both sides. So we are going to subtract or add negative b to both sides. So notice how we end up with a negative b on the right side, plus or minus that radical that's got the mess in it. Then we get rid of the 2a by dividing out the 2a to both sides. And so we divide by 2a. And we end up with, ta-da, this is what we would call the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we can find x if I know a, b, and c. Here we go. Keep track of that formula. First thing you always do is you check, is the quadratic equation set equal to 0? It is. Ta-da! So we know the a value is 2. The b value looks like 5. Be careful, it's negative 5. The c value is 3. So now we do some math. And we square b. So if I take negative 5 and I square it, I get 25. If I take 4 times 2 times 3, remember that's 4 times a times c, I think I get 24. So 25 minus 24 is 1. Woohoo! You did the toughest part of the formula, by the way. This part of the formula even has a special name. It's called the discriminant. Go ahead and write that down. All right, now I'm going to use and do the rest of the formula. Notice we've done the inside of the radical. So now I'm just going to finish up and do the rest of it. So opposite of b, again, b was negative 5, so negative 5 becomes positive 5. Inside the radical, we figured out that was going to be 1. And then I'm going to divide by 2 times a. So 2 times 2 is 4. All right, so this is going to be, I'm going to write this as 2 problems. Why is it 2 problems? Because notice I have a plus and a minus. So it's 5 plus or minus the square root of 1, which is 1, over 4. I'm going to quick figure that out. 5 plus 1 is 6 over 4 is 1.5. And then I'm going to do 5 minus 1 over 4, which is 4 over 4. So the answer is 1. So here are my 2 answers. X equals 1.5 or x equals 1. All right, we're going to do this 2 more times because it's so much fun, and we have to look at special cases. So in this case, the temptation is to do this. Can you tell that that's a mistake? Because it's not set equal to 0. So we have to do a little bit of work first. We're going to add 1 to both sides. And now we have 4x squared minus 4x plus 1 equals 0. All right. Again, start with the stuff inside the quadratic equation. So that's that stuff. So if I square the b value, I get 16. Negative 4 times negative 4. And then I square the a value. Or no, I take 4 times a times c. So 4 times a times c. Okay, and I think that's going to be 16 minus 16, which is 0. Yay, the discriminant is 0 this time. That's going to make the problem a little bit easier. So now I'm going to say x equals the opposite of b. So again, I take the opposite of negative 4, which is 4, plus or minus the square root of 0. Yay, that's just going to be 0 over 2 times 4. So I'm going to get my first answer to be 4 plus 0. I guess I don't really need to write that, over 8, which is 1/2. And then my second answer is 4 minus 0 over 8, which is also 1/2. Oh, so I have just one answer this time. X equals 1/2. Not 2 answers like I did last time. So this means, again, the parabola is just touching the parabola at, or the x-axis at one spot, not 2 places. All right, our third and final. Again, notice we don't have 0. So always make sure that the first thing you do is set your equation equal to 0. And so we get 6x squared minus 2x plus 3 equals 0. List your three values. And now start again with the tough part. B squared minus 4ac. So in this case, b squared is going to be 4 minus 4 times 6 times 3. Well, now I'm going to get 4 minus 72, I think, is, if I did the math right, 24 times 3. 4 minus 72 is a negative number. It's like negative 68. Ugh. Can we take a square root of a negative number? You should say, no, you cannot do that. So I don't even need to keep going because part of my problem is going to have the square root of negative 68, and we can't do that right now. Later on, we learn how to work with that. So right now, you say this is impossible. There are no solutions. And we should be careful here. We should say there's no real solutions. There are solutions to this problem, just none that we can do right now. All right, well, best of luck as you do those problems. Once you do those 6, these first 3 you actually solve. These 3 here, it just says, how many solutions do you have? So you're going to say there's either 2 solutions, 1 solution, or no solutions. All right, and again, you can tell that by looking at that first part, what we call the discriminant. Do that part always first. If you get 0, then you know there's 1 solution. If you get a positive number, then you know there's 2 answers. And if you get a negative number, like we did here, then you know that there's 0 solutions, no solutions. All right?